Awesome. Fantastic. So this is a session on deploying enterprise certificates or on-premises certificates using Intune. Thanks for having me, Greg. I appreciate it. Thanks for the group for having me as well. I was in town here for the Tech Mentor Conference. I gave this talk this week. I did not have time to redeploy my slide deck, so you're going to get all of the Tech Mentor stuff here. So sorry about that. But the content's fantastic. I think you'll certainly enjoy it, and welcome everybody online as well too. I see a lot of familiar names and have some familiar faces here too, so this is great. So for those of you who don't know me, my name is Richard Hicks. I'm the founder and principal consultant at Richard M. Hicks Consulting. You can visit my website at richardhicks.com. You can find me on Twitter, which is my social media platform of choice, at Richard Hicks. I am I'm a consultant that focuses on two rather niche areas, and they're kind of related, and that is secure remote access and enterprise PKI. So I do a lot of work historically with solutions like Microsoft Direct Access and now always on VPN. And of course, that would be pivoting to Microsoft Entra Private Access as well, which is a new solution that's come out. But I also do a lot of work with certificate services and PKI, ADCS work and things like that. Those two technologies are kind of interrelated. So although my disclaimer is I'm not a systems center expert or an Intune expert, I have deep knowledge and experience in very specific aspects of these cloud management solutions, specifically delivering certificates with Intune. Bit of shameless self-promotion here. I do have a couple of books. This is my latest book, Implementing Always on VPN Implementing Always on VPN, and also have some courses on Pluralsight. You can find out more about those by going to aovpnbook.com or richardhicks.com/Pluralsight. So for the next hour, we're going to talk about a few things Intune and certificates. I want to cover off on some of the common use cases. We're not going to cover all of them. I'm going to cover the most common or the most popular ones. Talk about some of the associated risks that come along with delivering certificates with Intune. It's not terribly difficult to do this. It just has the potential to introduce some potential problems in your environment that could leave your organization exposed. And I want to make sure that you are well aware of that. We're also going to talk in detail about how to mitigate some of those risks. There's a couple of different ways to deploy certificates with Intune. There's no one specific way. You have some choices to make there. They have advantages and disadvantages. I have a preference, and I will explain to you why that is, and we'll go into detail about that. Security best practices we will cover off on at all points in this talk, because at the end of the day, when we're deploying certificates, one of the things that I like to remind folks about is that just because you are deploying certificates does not mean they are inherently more secure than any other ID. And in fact, if you do certificates wrong, they can actually be weaker than usernames and passwords. And so we're going to talk about a couple of scenarios in which you could very easily make things really, really bad for you in your organization. And of course, I'm going to have a couple of demonstrations here as well. So common use cases. Anytime you're doing any sort of user and device authentication, you can use certificates for either of those scenarios. The two most common workloads, certainly that I get involved in, are Wi-Fi and VPN. Direct access required certificates always on VPN, although technically it can be deployed without certificates. You wouldn't want to because it's not a good idea. We want to use certificates anywhere we can, mostly and especially for secure remote access, simply because a properly managed user authentication and device authentication certificate provides a higher level of assurance than usernames and passwords. Usernames and passwords are easy to compromise and steal. That's why we have to have MFA. Digital certificates, when provisioned properly and with care, are a phishing-resistant form of multi-factor authentication. So typically what I'm talking about there is managing private keys and protecting private keys with Trusted Platform Module, or TPM. TPM ensures that the certificate, or excuse me, the private key for the certificate cannot be exported even with local administrator access or physical access of the device. The other scenario that is becoming more common is email document signing, document encryption. I've helped a few organizations deploy certificates to do those types of things. There's also another scenario in which you can distribute a PFX file. So literally a certificate, private key, perhaps a certificate chain. A PFX is basically, it's almost like a zip file, but it has a bunch of stuff in it. If it has a private key, then you can protect it with a password and so forth. I haven't run across any use cases for PFX distribution, but at this conference, somebody reached out to me and says, oh yeah, we have kind of like an authorization certificate for a particular application, but doesn't have to be necessarily user specific. So we just push one certificate out to everyone. There may be some other use cases that I'm just not aware of because I'm not exposed to those. We're not going to cover that necessarily in our talk today, just because I only have an hour-ish. So we're going to focus mostly on user and device authentication here. So as I mentioned before, just because we can deploy enterprise certificates using Intune doesn't mean that we aren't going to introduce additional risk when in fact you actually are. I want you to be aware of what those risks are, and we're going to talk about how you mitigate them. Specifically, the infrastructure in which you deploy your certificate, your Intune certificate connectors on can be problematic because in some deployment scenarios, it can expose some of your sensitive systems to the public internet. Specifically, what I'm talking about here again is the Intune certificate connector server or servers. You can have multiple. And in some scenarios, we actually have to publish this to the internet. And there are some limitations associated with that. So there's some great risk that we incur. We'll talk about that in a little bit more detail later. In addition, we're going to create a certificate template that the Intune certificate connector server is going to use to enroll for certificates on behalf of those Intune users, right? So essentially the certificate, Intune is really the proxy or the broker. The communication channel is the certificate connector. It talks to Intune, also talks to your enterprise or your online issuing CAs, and so it brokers that communication. The certificate template that the Intune connector uses to enroll certificates on behalf of users or devices is inherently risky and in fact is high risk. And so here's the deal. I bring this up because normally you would not do this, what we're going to do, but it is actually required for Intune to work. When I get to the demo, I'll explain in detail. I'm just telling you that if you're going through the Microsoft documentation and it says do this, do this, do this, know that when you're doing those things, you are potentially exposing you're intentionally creating kind of a bad implementation practice by design, but ultimately it's required for the workload. And again, we'll talk about that in detail a little bit more. So as I mentioned, there's a couple of different ways to deploy certificates. There's not just one way to do it. The first way to do it is with something known as PKCS, and that actually stands for Public Key Cryptography Standards. There's a couple of different flavors of PKCS. One of the things about using the PKCS option to deliver PKI certificates via Intune is that it is very easy to deploy and manage. It doesn't involve any direct internet exposure, meaning when you install the certificate connector and use PKCS, it just needs to communicate outbound. It is much like, in fact, it's identically like using the Azure application proxy. If you're familiar with Azure App Proxy, you install that server software on your servers on premises. It talks outside. Boom, I can access my private web applications without having to open up ports of my firewall and allow traffic into my internet or from the internet into my private network. The advantage of PKCS, and again, this kind of goes with the easy to deploy and manage piece, is that there are no additional roles and features. You literally install the Intune certificate connector on a domain joined member server, and that's it. You don't have to install any roles or features. You just have to install the connector software. Now, the other option is SCEP, and for those of you doing systems management, you're probably familiar with this. And by the way, when I ask this of a large group, who's deploying certificates with Intune today, almost invariably, most folks are doing it with SCEP because that's the way we've always done it, or that's the guide that most people were using that said to use SCEP, and so you use SCEP. Awesome. And in fact, there was a time when you had to use SCEP because PKCS wasn't around. And when PKCS was first introduced, it only supported user certificates. So if you needed to do a device certificate, you were screwed and you had to use SCEP. So I used SCEP for many years until the day that Microsoft introduced support for device certificates in PKCS. That was the last time I've used SCEP. So SCEP, although it works and works quite well, it has some advantages over PKCS. It is a bit complex to configure. If you've ever done this, you know there's a lot of steps you have to do. Miss one of them, stuff won't work, and it's very, you know, you're kind of like a turtle on your back. It's kind of challenging. I certainly struggled getting NDES and SCEP to work back in the day, and it can be challenging. SCEP is the certificate, simple certificate enrollment protocol. When you want to deliver certificates with Intune using SCEP, then you must install NDES on a Windows server before you install the connector. So NDES is the Network Device Enrollment Service. It is Microsoft's implementation of SCEP, right? The challenge here, of course, is that when you're using SCEP, you must install NDES and then install the certificate connector on the NDES server, but you must also publish it to the internet. So in this case, I do have to make this available publicly. I have to allow access from the internet into my NDES server. Now, there's a couple of different ways to do this. Small shops oftentimes just punch a hole in the firewall, ACL, NAT, right, and let traffic come in from the internet right to the server. Not a good idea if you can avoid it. If you're a small shop and that's all you got, awesome. The best way to do this is probably Azure Application Proxy, which I talked about a minute ago, because it doesn't require inbound access. So that's a much better way to go. But any ADC, Application Delivery Controller, load balancer, is a better alternative to just doing ACL and NAT. But at the end of the day, we must expose our SCEP server or our NDES server to the internet. And you cannot allow, or excuse me, you have to allow all traffic in because obviously you don't know where your clients are, and you can't authenticate them either because we're trying to get them certificates so we can authenticate them, right? So you have a circular dependency there. You had to do that. So let's talk about the security ramifications of those scenarios in terms of PKCS and SCEP. So either scenario requires you to install the Intune, the certificate connector for Intune, which is a download from Intune, and I'll show you how to get that later. Very easy to install and configure. It's stupid simple. The problem is that when you install it, I want you to be aware that this server that you installed this software on just now became a control plane asset. So control plane asset is the Microsoft privileged access model. So it's the control plane asset. In the legacy tiered model, this was a tier 0 asset. That might be more familiar to some of you. But at the end of the day, this becomes a highly privileged system by virtue of the fact that you've installed the certificate connector on it, right? In either scenario, SCEP or PKCS. So keep that in mind that once you install the certificate connector there, that this resource now should be monitored and secured as you would any of your other highly privileged assets like domain controllers and issuing CAs. So once you install this server, make sure that you are protecting it and monitoring it and watching it closely. And the reason for that is because this server has access to that template that I was talking about earlier that is high risk. If an attacker gains access to the template, they can do bad things. I'm going to talk about that here shortly. The problem is that SCEP introduces some additional security risks that are not present with PKCS. So SCEP, when you're delivering certificates with SCEP, you must install the NDES role. NDES installs IIS. And I just said, prior to this, that when you install the certificate connector, this is a tier 0 asset or a control plane asset. So my question, and this is more of a rhetorical question, is if you were building a domain controller, would you be comfortable installing IIS on the domain controller and publishing it to the internet without any authentication? The answer is absolutely not. That would be suicide, or that would be insane. That is exactly what you're doing with NDIS and SCEP. So I try to avoid using SCEP all the time simply because it is a huge security risk in most organizations. That being said, and again, we don't have this problem with PKCS because we don't have to allow inbound access, right? It just connects outbound. Herein lies the problem, is that PKCS will work in probably 99% of the deployments out there, but there are some scenarios in which you must use SCEP. I personally have not encountered them. Everything that I get involved in and that I work with, I've been able to use PKCS without issue. You can use PKCS to issue user and device certificates to Windows, iOS, Android. You can do it to all the mobile platforms. So I haven't encountered a scenario in which it didn't work for me. What I have been told by some of my systems management professional friends is there are some scenarios. One of them was when the device does not have a primary user. So if it's like a kiosk device, then you can't issue certificates with PKCS. You would have to use SCEP. So in those scenarios, and I would say those are very limited scenarios, if you have to do that, you will have to do SCEP, but you will have to accept that additional risk. We're going to talk a little bit later about how we're going to mitigate and reduce some of those risks, though. But I'll warn you that if you're following the Microsoft documentation, you're probably at great risk today. So, all right. So with PKCS, you have the option, actually, with both PKCS and SCEP, you have the option to run the connector as a service account or as the system account. I want to avoid using the system account as much as possible because it gives overly broad access. We're using the account that we're running under is what we're going to use to grant permissions on the CA, on the issuing CA, to enroll for this certificate. And so if I have a system account, if I compromise the system, I now have access to this template. So all I need to do is just pop something on the box, boom, I'm on, I get access to this template, and I'm going to show you later how bad that template is, or how easily someone could leverage it for evil. If you use a service account, I can compromise the Intune certificate connector server, but once I'm there, I have additional work to do. I would have to compromise the service account that it's running under. Hopefully that's, a long complex password, and I'll talk about some of the additional policies you'd want to put in place to further restrict access to that to reduce the chance of compromise. Unfortunately, Group Managed Service Account is not supported for PKCS. That would be the best answer, right, is to set up GMSA. It is not supported for PKCS, unfortunately. And as I mentioned before, and I'll show you the guide that I produced for performing additional security hardening for the service account. So we'll do things like grant or remove some access policies, enforce some login restrictions, and make it prohibitively difficult to compromise that or to access that certificate by someone who's not authorized. So with SCEP, we always want to use a group managed service account. The certificate connector does not support using GMSA. So when you install that, you'll have to install that either as system or as a domain service account. But then later, what you'll do is after the installation, there's some custom configuration you will do to set up the application pool in IIS to run as a group managed service account, and that's supported. There's some great guides out there, it's fairly straightforward. It's not super straightforward, but there's some good guides out there that would help you do that. Again, publish the SCEP server or the NDES server using application proxy. That's the best practice. Alternatively, use reverse proxy or ADC, and like I mentioned before, try to avoid ACL and NAT. That's highly simplistic way of granting access. So what are the things that we need to have in place in order to prepare essentially for delivering enterprise certificates? First things first, we need that service account. The service account doesn't need any special permissions. It just needs to be a domain user, not a member of any other advanced groups. It does need to be a member of the local administrator group on the Intune certificate connector server, and that's because that service account is creating, in the PKCS scenario, is creating the key pair there. So it needs to be able to have system level access. So it needs to be a member of the local administrators group, and it needs to be granted the log on as a service right. Other than that, you just need to disable enhanced security for IE. And this is mostly because when you log in to authenticate to Azure, if IE enhanced security is on, it breaks all kinds of stuff and you can't log in. So disable that before you start installing the connector. So let's talk about deploying certificates. What do we need? Obviously the Intune certificate connector, right? We need a domain joined Windows server. And by the way, for the rest of the talk, I'm going to be focusing on PKCS. I only have an hour. If I had an extra hour or two, we could probably go through the whole SCEP role. But unfortunately, I'm going to focus on the one that will probably work for 99% of the scenarios out there, and I think is the most secure deployment model for the reasons that we've talked about previously. So I'm going to stick with that. So we're focusing on a PKCS deployment. I need the Intune certificate connector. I'm going to just install it on a domain joined Windows server. Anything that's supported, the newer the better, obviously, but there's no specific requirements there. You could deploy it on 2016 if you like, or 2012 R2 for a couple more months. Unfortunately, it does not support server core. I'm a huge fan of server core. I don't know if anybody else is, but I try to use it as much as possible. There's some huge benefits to using it. This would be a very, very natural workload for server core because it's literally install it, log in and authenticate, and once I'm done, I'm done. And you will probably never go back to this server unless you need to look at event logs or something like that. But there's no ongoing maintenance. The certificate connector updates itself. I mean, it would be fantastic if this ran on server core, and it doesn't support it today. So unfortunately, you got to install it on for full server GUI. It does require, I'll qualify this. Historically, I understood that to install the certificate connector, you had to be an Azure Global Administrator. Somebody did tell me recently that that's changed. The original guidance was Global Administrator, but somebody said, oh no, they've eventually updated that, and there's another level of administration that's not Global Administrator, and I forget what it is. I'll have to research that. I usually just do it as Azure Global Administrator. You just need to be the global administrator when you're installing the connector. It doesn't run as the global administrator. It's just for the purposes of registering the connector with Intune. So it's just for the installation. So the reason I say that is because the user that you are installing the connector must have an Intune license assigned to it. Most people aren't, your global administrator accounts are not regular use accounts. They probably don't have an Intune account or an Intune license. So make sure before you go down this path, you have your Azure Global Administrator, you assign an Intune license. After you've done the connector registration, you can go back and remove the license if you wish. But just understand that installing the connector will fail if whoever you're registering it in Azure with does not have an Intune license. So for PKCS, we need to, basically, this next couple of slides, I just want to demonstrate the difference between the two scenarios. For PKCS, we have a server, we install the connector, and we're done. That's pretty much it. But for NDES or SCEP, we have to install the NDES role first. We then have to register an SPN. We also have to enable long URL support, update the max URL length, install and configure a public TLS certificate, configure the binding in IIS, publish that to the internet, probably using Azure App Proxy, so we'd have to set up Azure App Proxy, and then we can install the connector. So there's a lot of stuff you have to do with SCEP that you don't have to do with PKCS. But for me, the selling point for PKCS was the fact that I'm not exposing my control plane assets to the public internet. That's a huge win from a security perspective. I've had problems with customers failing security audits with SCEP because, again, we have a control plane asset that is published to the internet, and without pre-authentication, you can't do any sort of pre-auth for that. And so PKCS is definitely the way to go. So in terms of demonstrations, I want to show you the installing the connector And actually, I'm probably not gonna, well, let's do it. How are we doing on time? What time, we gotta start a little bit late. When do you want me to finish up?
15 or 20 after.
20 after, okay.
30,
All right.
35 minutes.
So, 12:15?
Yeah, yep.
All right. I'll skip this part because it's kind of boring. But I just want to make one interesting point here. So first of all, we need to get that Intune certificate connector. So to do that, you will go to intune.microsoft.com. Bigger. We're going to go over here to tenant administration. And then we'll scroll towards the bottom here. No, sorry, it's at the top. Jump ahead. So tenant administration, connectors, and tokens, and then scroll to the bottom. And we're looking for certificate connectors. And so you'll see here in my environment, I already have a couple installed. And so in order to add one, we just simply click the add button. Unfortunately, the add button does nothing more than just give you the link to the download. So you just click on this certificate connector link. And what's going to happen is it's just going to download it to the connector, right? So once we've done that, we'll go back to our server. I'm going to go back to my server. I've got it installed, or I have it downloaded here already. One of the things, there's two things that I want to make a quick point on. I'm not going to go through the whole thing because I want to save some time. But what you'll notice is that if you just double click on this connector, the software, let's make this work. Really? There we go. As soon as you check agree, you'll click install here and it will elevate. But it doesn't work reliably for some reason. What I have found is that it works much more reliably if I simply right click and choose run as administrator. In principle, I think this is the same thing. I have no idea why, but I have found that it will fail probably 9 times out of 10 if I just run it the normal way. But if I right click and choose run as administrator, it just works all the time. So
same people that designed the Exchange installer, evidently.
right. So I have heard other people say, yeah, I've run into that before. So I either run it there or I run it at the command line from an elevated command window. So I don't know why, but what I have found is that it consistently fails at installing the service. So I don't know if you didn't elevate early enough or God knows what, but anyway. But bottom line is that the connector is really just next. The only thing that I want to demonstrate or want to call to your attention here is that there is one particular aspect here is this PKCS. So by default, I think PKCS imported certificate is checked. So you'll uncheck that. Since I'm using PKCS, I've checked that. SCEP is not checked by default. You can check that if you want. And by the way, there's nothing that prevents you from doing PKCS and SCEP on the same server. I don't know why you would do that, but I would prefer if I'm going to use SCEP, I would probably have that on a separate server, but you can do both. So if you do have a scenario in which you have to use SCEP certificates, you can actually do it on the same server and even on the same connector. But also you'll note here that it says certificate revocation. This is a really, really cool feature of the Intune certificate connector in that anytime we issue a certificate, user or device, to a user or an endpoint, as soon as that certificate, the device configuration profile or the certificate deployment falls out of scope for that user or device, Intune will remove the certificate from the device, but it will also go back into your CA and revoke the certificate for you. So basically performs certificate lifecycle management for your endpoint devices. So you onboard a whole bunch of people and all of a sudden that device gets wiped, reloaded, or you retire it, or the user moves on, or the user moves to a different group, doesn't need remote access or whatever they need the certificate for. The certificate profile doesn't apply to them anymore. Boom. Intune recognizes that, goes into the CA and revokes it. Other than that, this is literally next, okay. You'll have to put in your credentials, accept your MFA, and that's it. Once that's done, you'll need to come back into this particular console. And what you would see here is you would have another one, and it would have a name, and this name would be rather nondescript. I think it has the date and the time and something else in there. I always recommend changing that, and you can actually do that just by clicking, oops, not there, by just clicking on the connector. And then once you do that, this field is editable. So the name field, you should always edit, because if you install more than one connector, and I would encourage you to do that for redundancy, but anytime you have more than one connector on separate servers, if there's an issue with it and it doesn't show it as active, I would really like to know which one that is. I usually put in the server name here. You can put in whatever you want. Just make it something that identifies where this connector is installed, because again, the default is kind of generic.
And there's no connector that shows the configuration. I mean, that, from the Intune perspective, you get almost no information about what the connector is talking to.
Correct.
I know because I just checked what they did.
Absolutely. So you're absolutely right. So the comment here is there's no information on what the connector is capable of doing or is doing, right? And that the reason for that is the connector is sort of generic. The connector is really just pipe, and you define what in the device configuration profiles, what it is you want to do, whether it's going to be a PKCS or SCEP certificate, whether it's going to be user or device, which CA to enroll, all of that stuff. So moving on. Once we have the connector installed, we need to do some configuration work on the CA itself. Specifically, we need to set some permissions. We need to grant the service account that we're running under issue and manage, because it needs to issue certificates, but it also needs to manage them. And by manage them, I talked about revocation. It would actually need to be able to revoke that. We need to create a certificate template and grant the read and enroll permission for that particular service account. And also, this is critically important, we need to remove enroll for any other principals, because you're going to find that when we duplicate a template, the default permissions are rather permissive and actually over permissive. So with PKCS, if you're not familiar with certification authorities and Active Directory certificate services, templates have different versions. There's version 1, 2, 3, and 4, and the newer, the higher the version, the more capabilities that certificate template has. But older operating systems don't recognize those new capabilities, and so you have to kind of tailor those to your target audience. So typically, we would want to use like a version 4 template because it supports all the latest features, like CNG, so cryptographic next generation, and TPM support, and all the good stuff that comes along with version 4 templates. However, PKCS can support no newer than a version 3 template. I always stick with using the version 2 template because there is no advantage to using the version 3 template. And so if we stick with the version 2 template, it's just going to work. If you're doing SCEP, it must be a version 2 template. It does not recognize anything newer than that. And so you need to be very careful with that. I've worked with a couple of customers who've implemented it on their own, couldn't get it to work. And the first thing I go and find is that they had a version 4 template. But nope. And the reason for that is that SCEP's an old protocol. It was introduced in the early 2000s, and it's been around forever. And it was kind of an antiquated protocol until we kind of revived it for Intune. But at the end of the day, it's just technology. It doesn't recognize the features in version 3 or later templates. So let's get on to the next demonstration. I want to show you how to prepare the CA and configure the template. So I'm going to jump onto, well, I'm not going to jump onto my issuing CA because my issuing CA is running server core. So here I am on my management workstation, and I'm going to open up my management console, basically, which is just an MMC where I install a couple of snap-ins for my CAs and my certificate templates. So the first thing that I need to do is go to my issuing CA, and remember I need to grant that service account some permissions. So I'm going to right-click on my CA, choose Properties here. I'm going to go to the Security tab, and I'm going to click Add, and I'm going to add my demo account. This is my service account that I created in Active Directory prior to this. And then what I'm going to do is highlight that and grant that Issue and Manage, as well as Request Certificate. So that allows this service account to enroll for certificates on the CA, but also issue them and manage them on behalf of others. So, and And I need to do that on all of my issuing CAs. I just have one issuing CA here in this lab, but if I'm using multiple, I need to do it there. The next thing I need to do is prepare a certificate template for this service. And as a matter of best practice for PKI or ADCS administration, you never want to publish default templates and you never want to change the settings, the default settings of default templates. You should always, when you're working with templates, always start and duplicate one of the original templates. So I'm going to use the user template. And by the way, this template that we're creating works for both user and device. Even though I'm duplicating user, it works for both user and device when you're delivering certificates with Intune. So what dictates whether it's a user or device certificate is the configuration policy, which I'll show you here in a bit. So I'm going to right click and I'm going to choose duplicate template. And I'm going to uncheck show resulting changes right now just to eliminate some of this noise. But this is where we're going to define the template version. Now, it's not as easy as selecting version 1, 2, 3, or 4, unfortunately. It's not that intuitive. But what you have to do is in the CA is there's different flavors here that you would choose. And if I chose something like, 2008 R2, that's going to bump it up from a version 2 template to a version 3 template. And if I choose an even later version, it might jump it up to a version 4 template. So my suggestion to you is, since we just need a version 2 template, is just literally leave it as it is. So the default's a version 2 template, no changes required here. So if you're changing anything in here, you're probably going to break something, more than likely. All right, let's go to the general tab. We're just going to give this one a name. All right. And as I mentioned before, the name of this template could be generic. In other words, it's not user, it's not device, because it might be for either one. And then the next thing I want to talk about here is validity period. Validity period for certificates. The industry has kind of settled on about a 1-year default validity period for certificates, server or user, and we kind of stick with that. So I leave this at 1 year. You can change it. I would encourage you or discourage you not to make it any longer. You could certainly make it shorter if you wish. But at the end of the day, I usually leave it at 1, and that's usually sufficient. I do want to talk about this little option here, publish certificate in Active Directory. This is probably the single most misunderstood setting on a certificate template. And a lot of administrators think that in order for me to see this in AD, like when I go to enroll for a certificate and see it in the list, that I must check that box. That is not true. That is a myth. So you should uncheck this. By the way, when you check this box, it doesn't make it visible in AD. What makes it visible in AD is publishing the template on the CA, which we're going to do in a second.
That's talking about the certificate.
This is
not the
talking
template.
about publishing the certificate when it is enrolled for in AD. So what that means is when a user or device enrolls on this template, publish it, that certificate that was issued by the CA, to its user or device object in AD. Normally, when you check this box, man, it just pollutes your AD, right? I have been working with ADCS for 15 years, almost 20 years now. I have never come across a scenario where I had to check this box. It is exceedingly rare. Some of the scenarios I think were email encryption. There was a few scenarios in which you had to have it. But I haven't, I do this a lot and I've never used this. The problem is this: if I check this box, everybody who enrolls for the certificate will have that certificate added to their computer or user object in AD. Awesome. One user enrolls for one certificate, great. This is a service account. It might enroll for thousands or tens of thousands of certificates. What's going to happen to this AD object in AD? It's going to get bloated. It's probably going to stop working at some point. So this is a real problem for this particular workload, which is this principal is going to enroll for a bunch of certificates on behalf of other people, but ADCS doesn't know that. It's just going to say, here's your certificate. It's going to drop it in your account, and you're going to have problems in the future, no question. But at the end of the day, it's just pointless. It's just adding to your AD database. So it's just no real reason to do that. So make sure that that's unchecked. Let's go to the request handling tab. You'll see that there's this allow private key to be exported. If you're doing PKCS, we need to check that. If you're doing SCEP, you can uncheck it. The next thing we're going to do here is go to our extensions tab, and you'll see that it has a bunch of policies here that are by default. I am a proponent of the principle of least privilege, and in this scenario, what I want to do, the only requirement here is client authentication. So I don't need EFS or a file system. I don't need secure email. So I'm going to remove those just because, hey, if this is an authentication certificate, that's all I want it to do. Great. So it has client authentication. That's all I need. Now, I'm going to come over here to the subject name. And here, by default, you'll see that it says build from Active Directory information. However, this is a process in which I can't do that because the principal, the user or the device, is offline. It's being handled by Intune, so it's being brokered. So in this case, I have to check this box called supply in the request. And as soon as I do that, you see I get a big scary warning message here that says, and I'll paraphrase, this is a bad idea. Unfortunately, this is by design. We need to do this because we can't get the user from Active Directory. It might not even be in Active Directory, right? So we're getting this information from Intune, and so the service needs to supply this in the request. So this is telling you, hey, this is potentially a bad idea. We have to click through this and accept that. Now, herein lies the problem. I now have created a very, very dangerous situation. And if you are reading the Microsoft documentation and you miss this or it's not in that documentation, you can get your AD owned in a second. Let me describe why. So we have subject name supply in the request. The extensions on this template are client authentication. What that means is that if an attacker were to gain access to this template as it's configured right now, they could supply a name in the request. They would get a certificate back with client authentication. By default, when you install ADCS integrated with Active Directory, that CA server is automatically given permission to authenticate users using their certificate, meaning I can authenticate against Active Directory simply by demonstrating that I have possession of the private key for this certificate. So there's a process called PKCS. I don't want to go too much into the weeds, but bottom line is that there's an exchange between principal and the domain controller, where the domain controller sends some information. I'll encrypt it with my private key. The domain controller decrypts it and says, yep, you own the private key. Here's your Kerberos ticket. So I'm going to publish this template in Active Directory, but if I go to the security tab, look who has enroll permissions for this template by default. If you miss this, an attacker will absolutely love you, because what they will do now is they'll have some domain user account. They'll find this template. It has subject name supplied in the request, so they will just supply domain admin at yourcompany.com. They'll get a certificate back, and they'll have the private key. And at that point, they can authenticate against your directory with that principal without having to know the password. So if you're not careful, what we're doing here can open your organization up to great risk. So what do we need to do? We need to make sure that no one else has enroll permissions. By the way, I would just remove domain users from this. But also by default, domain admins have enroll, and so do enterprise admins. Domain admins and enterprise admins certainly can have read and write, but you want to make sure that they do not have enroll. And then also we need to add our service account. And we need to grant that service account read and enroll. So the service account becomes critical. An attacker gets a hold of that service account, they would have access to this template. They could create a certificate for any principal they wish, and so that would be game over. So what we want to do is make sure that we have a long, complex password on our service account, that we are monitoring usage of the service account, all the security things that go around that, because again, this is a highly privileged account and a highly privileged template. All right, so at that point, we're good to go. And we need to publish this template. So you would just simply go to your certificate templates, right click, choose new certificate template to issue. And let's see if we can find it. So PKCS demo template. By the way, if you have a, this is just a lab with 2 domain controllers, right? It's a flat network. If you have a large network, lots of domain controllers, you may not see this template immediately. Keep in mind that you have to go through some AD replication in order for that to show up. So be patient there. But I'm going to publish that. And at this point, that certificate is there and available. Now, as I mentioned, that certificate is dangerous. What I want to do is bring to your attention another a bit of information here. We can't go over all of this just for time, but if you go to my website, if you go to directaccess.richardhicks.com, go into the search field there and just type in PKCS, you will get an article here. The first one that shows up is all of the security hardening options you would do for the certificate, or excuse me, for the service account, right? So account hardening, so we want to restrict access to which servers it can log on to. We want to make sure the account can't be delegated, it's marked sensitive, remove dial-in. There's a bunch of things on this that will basically make it really, really difficult, even if somebody had the password for this account, to be able to access that template. That template's got to be guarded with your life because, again, if an attacker gets a hold of it, if they compromise one of your domain administrator accounts, well, the game's over right there anyway. The important thing is that you can authenticate with this certificate without knowing the password, which means I can change the password to my heart's content, and that certificate will still be good for authentication. So at the end of the day, I want to make sure, in that case, I would probably disable or delete the account, but at that point, game's probably over anyway. All right, let's get back to, I think I covered off on everything, right? Yeah, we created the certificate template. Okay, we provisioned it. Okay, cool. Now, let's see if we finished that. And, got it. Okay, so now, all of our infrastructure on premises in place. We have the connector installed. We have our template created and we have it published. And so now we're ready to create our Intune profile. We do this using a device configuration profile. I'm going to run through some of the best practices here. And I really do this just so that they're on the slides for you. But we're going to run over all of this stuff in the demonstration here. So validity period, like I mentioned, 1 year or less is recommended. There's an option to select the KSP, which is key storage provider. Key storage provider is critical. As I mentioned, and now you know, the danger of digital certificates for authentication is that if there's a key compromise, an attacker can use that certificate to authenticate as that principal by demonstrating they have control of the private key. By default, when you issue certificates are a public, or let me back up. A certificate is a combination of the public and private key. The private key always stays private. The public key is a part of the certificate itself, right? So that's publicly available. The private key is stored by default as a file on the operating system, and it is just protected by an ACL. So really, anybody with local administrative access could access those private keys. Again, if I have that private key, I can authenticate. So we want to make sure that we store the private keys in a TPM because the TPM has additional protection measures in place that prevent tampering or access to the private key, even if you have local administrator rights. So we want to make sure that that happens. So there's an option to use the TPM, and there's an option to use TPM or fall back to software KSP. We don't want to do that. We want this thing to fail, and if it doesn't work, we want to know about it rather than falling back to an insecure method that I will never know about. Also, the template name, it is different than the display name. I'm going to talk about that in just a second. There are a number of ways when we're building our template, or when we're building our device configuration profile in Intune, there are a number of ways in which to set up the UPN, because the UPN is the most important part of this certificate template. And I'll talk about those shortly. But so for example, I usually just use user principal name because that just works, but sometimes it doesn't. And so I have to get a little creative. And to get the right UPN to authenticate, I might need to build it manually or do something else. So those are the options that you have available to you. For a device certificate, it's a little bit different. I typically use fully qualified domain name, but that's only available if the device is domain joined, so hybrid Azure AD join. If you're doing native Azure AD join and you need to do a certificate, then you'll use device name, but to get the FQDN, you have to build it yourself. And then here are some of the object identifiers or OIDs for common certificates like client authentication. By the way, you don't have to remember these. These are in a drop-down list. Well, this one is. I think the others might not be. The bottom line is, I'm just going to demonstrate that here in 1 second. I'm also a huge proponent of custom application policies. What that means is that a certificate with client authentication could be used to authenticate to the VPN, but it could also be used to access the Wi-Fi network. It might also be used to for SCCM. I know SCCM administrators will commonly deploy certificates for things. The problem here is that I might have multiple certificates on the endpoint for different things. Maybe everybody gets Wi-Fi, but only a subset of users get remote access. But if the Wi-Fi certificate would work for remote access, what am I doing, right? And so using custom application policies allows you as the administrator to more closely define that this certificate with client authentication must also include another policy on it that dictates it is only for VPN. And it cannot be used for Wi-Fi or authenticating to SCCM or something else. And I'll talk about how you can do that here in just a bit. So let's get on to creating our configuration profile in Intune. And if you're familiar with Intune at all, this will be a lot of review. But essentially what we're going to do is we're going to come back over to devices, configuration profiles, and then we're going to create a profile. Now, real quickly, if you are deploying certificates to Azure, to hybrid Azure AD joined devices, you can continue just creating the certificate deployment profile. If you are creating, or if you're publishing certificates to native Azure AD joined devices, you have to all first publish your root CA and any intermediate CAs as well. In other words, we need to make sure that our devices trust the CA from which we're issuing the certificates, right? So again, hybrid Azure AD join gets those certificates part of the domain join process. Those certificates are in AD, they get pushed down to every domain join device, but for native Azure AD join, they don't, so we have to go get them. So to do that, before we actually create the profile, I actually need to get those certificates. So I'm going to jump back over to my server, and there are numerous ways in which to get the certificate chain. You can do it the command line, and you can do it. There's a whole bunch of ways to do it. I have one way that I like to do it, and that is to go onto an issuing CA or any server or workstation with the remote server administration tools installed, and just simply type in PKI view .msc. So PKI view.msc. I have an ulterior motive for using this method, and I'll explain it to you in a second. But bottom line is that once you come in here, you will see one or more issuing CAs, or CA hierarchies, I should say. I have two in my lab. They're for two different things. The one I'm interested in right now is my RSA, or standard issuing CA. And this is the root CA, and this is the issuing CA. I might have multiple issuing CAs below that. But bottom line is I need to go here to the root, and if you'll notice, there's a CA certificate. If I just right-click on that, I can view it. When I view that certificate, I can go here to Details, Copy to File, Next, and then I can export this. I usually recommend base 64, and then choose Next, give this a name, and save that out somewhere. And I would repeat that also for the issuing CA. So I'd highlight the issuing CA, go here to CA certificate, right-click, view, blah, blah, blah. So as I mentioned, there's multiple ways to do this. The way I recommend using PKI view is my ulterior motive is that a lot of people don't even know this tool exists. And when you open this, you're probably going to see a bunch of red X's in here and go, oh, my PKI is unhealthy and I didn't even know. I can't tell you how many times I show this to console to people and they're like, oh, I've never seen that before. So this kind of gets me to look at the health of your CA and see, is it really healthy or is it not? If there's some problems, if it's misconfigured, you'll see that in here. So fortunately, mine's healthy, but at the end of the day, there are other ways to get those certificates. So once we have those certificates, then we'll come back over here, choose Windows 10 and templates. And if you search on certificate here, what the heck? There we go. You'll see I have a variety of options, PKCS, PKCS supported SCEP. Trusted certificate is where you would deploy your root and issuing CAs. So I'm going to choose trusted certificate, create, we'll give this a name, and literally it's just going to ask you for the file. All right, so it's just a file, you're going to push it out. And then where it goes, it always goes in the certificate store, computer certificate store root. Any certificates in the computer certificate store are available to all users on the system. So that's where that would go. If this was an intermediate, then I would select computer intermediate and put the intermediate in the intermediate store. Once that's done, I will push that out to probably all devices, all users, because everybody should get that. Once I'm ready to create my device configuration profile for the certificate itself, I'll click Create Profile, and where am I going here? There's 10 templates, and I'll just type in certificate again, and I'm going to use PKCS certificate, create, give it a name, choose next. And then it's going to ask me for some information. Let me zoom in and make that a little bit bigger. So the renewal threshold means when can this certificate, when should it start to renew or look to renew itself? Within 20% of its valid lifetime or valid remaining lifetime is kind of a standard. So at 20% of its life, it will start to try to renew. And that's kind of standard. I wouldn't reduce this. If you have any concerns about timely renewal, you could increase it. The only disadvantage is you might issue more certificates than you might otherwise, but I would not recommend reducing that. Same thing with the validity period. I do have customers that want to make this longer. I try to encourage them to stick with standard best practices and make that a year. This is the one that I was telling you that was really critical here. This is the key storage provider. I recommend using Enroll the Trusted Platform Module or TPM, otherwise fail, because I want this to be secure. And if it's not secure, I want to address it. Why don't you have a TPM? Why is the TPM not working? What's preventing me from using the TPM on this device? Rather than just say, the TPM isn't working right now, just go ahead and put it on the file system and save it. So you may have scenarios in which you must enroll a certificate on a device without a TPM. Maybe it's a virtual machine without a TPM. By the way, most virtual platforms support virtual TPM. I would say fix that. But maybe it's servers you need to log on to that need this certificate. I don't know. At the end of the day, you may have some scenarios in which you have to enroll for on a device without a TPM. I would say create those as an exception. Create a different device configuration profile with a shorter lived certificate. Remember, anybody who has access to the private key can log on as that user. So if this private key is not well protected, I want to make sure the lifetime of that certificate is much shorter. Maybe it's 30 days, maybe 2 weeks, maybe even 7 days. It's up to you. At the end of the day, just be cautious of that. But I would also, and I worked with another customer where we created this policy that you could enroll for a certificate without a TPM because they had some older laptops. They were a nonprofit and some pretty old machines. And so our policy was you could enroll for it, but it's an exception. You have to get sign off from your manager and you're accepting the risk, and then we'll assign it to you and the certificate's good for 30 days. So at least we're rolling those over. But at the end of the day, we want to get those updated. The certification authority is the host name of the CA I want to use for enrollment. So I can have multiple connectors, but ultimately this connector or this profile points at this server. So that's kind of a single point of failure right here, meaning if this CA is offline, and by the way, I'm going to use my FQDN. If this CA is offline, then this certificate won't enroll. So hopefully that's not a huge problem. It's not been a showstopper for any of my customers, but just understand you can have multiple connectors. But this is the single point of failures. I could have 5 different issuing CAs, but I'm only going to point to one with this profile. The certification authority name is an interesting one. So it says, if you look at the tooltip, it says a friendly name for the CA. You can't just use any name here, unfortunately. You have to use a very specific friendly name. So if I go back over to my CA or any, you can actually just run this on any domain joined machine. Just run the command certutil, CERTUTIL, without any parameters, and you're just, it gives you a bunch of information. The name of the CA is what I'm looking for here, the friendly name. It doesn't say friendly name, but it just says name. This is actually the string that I'm looking for right here. And if you have multiple CAs, you need to make sure you grab the right one, the one that corresponds with that. So you can see the FQDN is listed in here. So this is the name that is associated with this particular CA. So I'm going to copy that. I think I copied it, right? And then I'm just going to paste it in here. And if you get the quotes in there, you don't need those. Gosh, that drives me crazy. So make sure you don't use the quotes if you're copying that. And then the template name. This is interesting as well. Remember, I mentioned that the template name is different than the display name. So if I go back and look at the certificates, all right, that's the end of that demo. Good times. My other one up. Let's see if this is up. Well, I just lost internet or lost. Let's see here. Oh, I can't. Yeah, I can't look at that, can't I? Nope. I wonder what happened. That's weird. Try logging back in. Just got temporarily kicked out of RDP for some reason. That was weird. Apologies for that. And I'm going to wrap up here in just a second.
We got about 10 minutes before the pizza arrives, so.
Okay, cool.
Take what you'd like.
Okay, cool. I'm going to do it then, because I got a couple more things here. All right,
We
so.
can eat while we watch.
That's right.
Absolutely. Oh, I'll keep going. I could go all night. So anyway, so I'm going to go back to this console here. And so you'll see here, these are all of the certificates that are published. And if they have spaces in them, that is actually the display name. So I'm going to go back over to my templates. Remember that PKCS demo that I created? Let's see here. So PKCS demo template, if you'll notice here, the template name has spaces, the template display name does not. So essentially by default, the template name is the template display name without spaces. So if you copy the wrong one here, this won't work. You must copy the template name, not the template display name. So it's PKCS demo template. So let's check a look at that. So PKCS demo template. So again, this is a common area that I see admins trip up on is they put the display name in there, not the template name. So this is a user certificate. If it was going to be a device certificate, I would select device, but I'm going to choose user. I always recommend, by default, it puts in email address. I always recommend taking this off simply for 2 reasons. One, it's not needed. It's not needed here in the subject name format field. 1. 2, if it is there and it's not on the AD object, the certificate enrollment will fail. And I cannot tell you how many organizations that don't reliably or consistently put the email address on their AD objects. So in that scenario, I just eliminate that problem, just call it username. And then same thing here for the alternative name. I'm going to select from this drop-down list. There's a couple of canned items here. I'm going to select UPN. And then the value is going to be that variable, user principal name. Right. And by the way, there's a list of the supported variables on the Microsoft website. I don't have that link up right now. Unfortunately, I should have it up. But there's a whole bunch of variables that are available to you. If you just look up Intune certificate deployment, you'll run across that. I only use a handful of them, but there's a whole bunch of other ones in there. So the extended key usage is where we're going to define our application policy. So from the predefined values, I choose client authentication. I'm good to go. As I mentioned before, I do like using custom application policies. If you want to do that, you would just put the name in here. Since it's a custom one, it's not going to be in this predefined list. You would just type in the OID and then go from there. Just make sure that that custom application policy is also on the certificate template that we created previously. So at this point, we're done. So we'll just choose next, assign this to a group. I am of the opinion that you deploy device settings to device groups and user settings to user groups, but if there's a reason not to do that, go for it. But I'm going to deploy it to my VPN user group, choose next, and at that point, we're done. So I've created this, and at some point, Intune will do its thing. It will realize that this is a VPN user in the VPN user group. It has this certificate policy assigned to it. It will collect some information and basically create a work object that puts in a queue. The certificate connector servers poll, because they only talk outbound, so they'll just poll that queue for work and they say, oh, somebody needs a certificate, grab the information. The connector server, if you're using PKCS, will create a key pair, have this public key signed by the CA, create the PFX, send it to Intune. Intune sends it back to the device. And Agnes, we'll get to your question in just a second, my friend. So anyway, so that's basically the process. And again, for the device certificate, all I did is select the device in that drop-down list. Pretty much everything else is going to be the same. It's the same template. And then there's different options for building the principal name because it's obviously not a user, so UPN wouldn't apply, but that's where we'd use some of those other settings. So at that point, eventually that will show up. Now, a word of caution, this does not happen instantaneously. It does happen a little quicker with SCEP, and the reason for that is that SCEP talks right to your server. But of course, that's a security risk, so you have to decide how you want to accept that. More often than not, the delay, because there's a bit of a handoff and relay there with PKCS, is not a problem. The only time I've ever seen it become potentially pose problems is with some scenarios in which you need to get a certificate down to a device as a part of some process. For example, the most common one is autopilot. You're doing autopilot, you're doing offline hybrid Azure AD join. And my answer to this is, of course, don't do hybrid Azure AD join. But anyway, if you're doing hybrid Azure AD join and you're doing it remotely or offline, I need to get the certificate on the device so that when the user logs on, it establishes that device tunnel so it can talk to a domain controller. And if there's some delays there, you might not have gotten the certificate prior to the user being ready to log in. So just really depends on how fast you run through your deployment. Eventually that certificate will get in there and you'll be good to go. But sometimes it doesn't come instantaneously. Be patient. The risk reduction is well worth the reward, I can assure you. All right, cool. Let's see what else we got here. Awesome. Okay. Gonna wrap it up here, probably 5 minutes, but I just want to talk about something very important because it has some ramifications to how we're delivering certificates with Intune. Oh, sorry, Akos asked a question there. Can you?
Yeah. If the PKS setup and on-prem is so easy, why do people love SCEP?
Oh, okay, great. So excellent question. So the question is, if PKCS is so great, why do people love SCEP so much? The difference there is that SCEP is a service, right? So SCEP is a service. It's a cloud service that is basically a cloud-based CA. Everything that we're talking about here is for delivering your enterprise PKI certificates via Intune, but the assumption is that you have a functioning enterprise PKI. I've probably been using it for years for a wide variety of things, and now as I'm moving into the cloud and Intune, I want to continue to use those certificates. If you're doing a greenfield deployment, there are other options available to you. You could use a service like SCEP, which is a cloud-based PKI, so I don't have to manage any of this infrastructure. I just sign up for their service. The disadvantage or the drawbacks of those is that they come with a price tag. They usually are kind of expensive. Some of them, like some of the other managed solutions, like Keyfactor and Venafi, Some of those enterprise ones are just, they're a fortune. There are some free ones like Small Step, but I shouldn't say that. Small Step is not free. You can use some of their free services, but they're very, very limited. I wouldn't recommend using that for user or device authentication. It's more DevOps stuff. But at the end of the day, SCEPman's an alternative. It's a service that you could leverage if you wanted to avoid the complications of and the complexities of managing your own on-premises PKI, then SCEPman's a great way to go.
Do you know, is that license like per certificate issued or per
I
managed?
don't know for sure. I've never used it.
Just curious.
Yeah, so, but I think so. If you go at SCEPman.com or something like that, but you can usually find that. But yeah, there's a cost associated. I think it might be per device or per certificate per device, but there may be some other ramifications there. I'm not sure. Anyway, real quickly, wrapping up, I want to talk briefly about strong certificate mapping. So Microsoft in May of last year introduced this security update that when you install this security update on domain controllers and issuing CAs, introduced some new features, some security capabilities called strong certificate mapping. Essentially what Microsoft realizes is that there was the potential, and as it's been told to me, there were no known attacks, but it was more of a kind of a theory or a principle, like a in principle attack. Like technically this could happen, right? Where somebody could abuse the subject name process and create a certificate that had a different principle than you might otherwise anticipate, like using the $sign. Sometimes the $sign, I think the $sign was ignored, and so you could get a UPN back that wasn't exactly what you should have gotten. And attackers, they figured an attacker may be able to use this to gain access to accounts that they wouldn't otherwise have. So they introduced something called strong certificate mapping. It adds an extension to the certificate template that includes this application policy, and the data in this extension is the SID for the user principal, either the computer account or the user account. So now with the SID embedded in there, an attacker couldn't just arbitrarily submit a request and ask for this information. This update shipped in May of 2022 in compatibility mode, meaning that Microsoft's goal when they first introduced it was, hey, we're going to leave it here for you. It's in compatibility mode. If somebody logs on with a certificate or authenticates to AD with a certificate that does not have strong mapping, we're just going to log an event and let you know that happened. Once you get to a point where you fixed everybody, because when you first install the update, every other certificate you ever issued doesn't have this. So you would have to re-enroll all the old certificate holders. So there's going to be a period of time in which it's going to take to get all the certificates updated and things like that. And so you can't turn it on now, but Microsoft says, hey, you can either turn it on with this registry team whenever you're ready, or we're going to set full enforcement mode in May 9th of 2023. That was their original plan. They hit a snag. And that was that there was a compatibility issue and it has to do with Intune. So they pushed the date back, and I need to update this because somebody brought it to my attention that they actually updated it again. Originally, they pushed it to November 14th, and the Microsoft site said this or later. And I'm a firm believer in words mean things, and when they put this on there, I'm like, they were not confident about their original date. And sure enough, it's been pushed back to, I think, February 2025 now. But bottom line is this. The limitation was that there was no support for offline templates, which Intune uses. So they pushed out this update and said, in a year, we're going to change enforcement, but it didn't work for Intune issued certificates via PKCS or SCEP. So if you were delivering certificates via Intune, you were out. And people were going, hey, this is BS. We're remote access, Wi-Fi, we're doing all these things. We're authenticating against the domain with this, and you don't support offline templates. And they're like, yeah, we're aware of that. We're working to address it. And so anyway, it was also a problem, but it affects PKCS or SCEP. It was a problem for Azure conditional access as well, because you could set up Azure CA policies for authentication, and basically what that works for VPN, excuse me. The way that works is that the Azure's Azure issues a short-lived certificate to your device or to your user, and that is presented for authentication. And if that didn't include that SID, that would fail at the original enforcement date. So they eventually fixed this. They fixed this last week, as a matter of fact. So that's great. The on-premises PKI stuff is not fixed yet. We expect hopefully later this year. So you can't turn on full enforcement if you're using Azure, if you're using Intune certificate delivery. Last thing I want to talk about is certificate revocation. It has come to my attention that disabling certificate revocation by system center administrators was common practice back in the day. Some of my other friends that do a lot of system center work were like, oh yeah, we just disable it. That way it works everywhere. It's like,
Why would they do that?
don't do that.
Like, what problem would that ever solve?
Well, what they're doing is they're using internal certificates, but they're using them on the internet somewhere. And so the CRL is either an LDAP or an internal, host name.
Can't be reached.
And it can't be reached from the outside, so things fail. So their answer was, well, we'll just disable revocation. So anyway.
Turn it all green, huh?
Right. Yeah.
That's basically like ignore all possible security, right?
100%. So, I don't want to mention any names, John Market, but I had somebody tell me they do this on a regular basis.
Until John gets called out.
All right. So sorry about that, John. Anyway, you can avoid this scenario by using public certificates for public-facing workloads and using private certificates for private workloads. That's the best way to avoid this challenge. If you have something public-facing and you need a certificate, use a public certificate. That's the best way to go. At the end of the day, if you do need to publish your CRL to the internet, if you absolutely must use your internal PKI certificates outside, you can publish your CRL to the internet. It's optional but not recommended. If you're going to do this, suggestion is to use the CDN. So Azure CDN, which is a part of Front Door, is a great option for that. You can use, actually you can use Azure static websites. There's a lot of different ways you could do that. By the way, you could use anybody else's CDN or Cloudflare or Akamai or whatever. Basically, you just need to make a file available via HTTP, not HTTPS, HTTP, and it's got to be available on the internet. And then you also have to update the CA configuration, because you have to stamp that CRL into the certificates that are issued to say, hey, this is where my CRL is, and it's got to be that public CRL. Don't recommend doing any of this, but if you have to, you can. Last thing, the order is important. The order of CRLs is checked in order. And so if the first CRL is an internal, and sometimes it's HTTP or LDAP, but it's LDAP to your domain, or if it's HTTP, it's some private server that's not available on the internet. What's going to happen is it's going to fail and it's going to wait for 15 seconds before it tries the next one. So if your public one is third on the list, it's going to try the first one and wait 15 seconds. It's going to try the second one, wait 10 seconds because these are not reachable, and then finally get to the last one and go, oh, that one's available, I can get to that. So if you're going to do this, make sure your public CRL is at the top of the list. That brings me to the end of the show. Thank you, everybody, for hanging out with me. And the pizza's here, perfect timing. And if there's any other questions online, pop them into the chat. But other than that, I'm going to give you my information. If you have any questions at all, comments, suggestions, you can find me on Twitter, Richard Hicks. You can drop me an email. I answer email all the time. A lot of stuff we covered off on today. Thank you for your time. And let me know if there's any other questions, Greg.
You should add your link to your blogs.
What's that?
You should add the link to your blog.
Oh, I mentioned the in the front. You can go to richardhicks.com. But yeah, my blog is at directaccess.richardhicks.com. So if you're interested there, you can see that as well.
All right, thanks, Richard.
My pleasure.